we're going to talk about the elephant in the room, performance. Now, React Native is exciting, and we all want to use it because it lets us share things. There are many benefits, but people always ask one question: how does the performance compare to purely native apps? If I create my apps with React Native, will they measure up to the top apps in the App Store? So this is a very important question. And the purpose of today's talk is to give you some insights to this question. Okay, we're going to discuss a little bit how React Native itself works under the hood. We're going to discuss some of its limitations, inherent limitations of performance. And of course, we can talk about what you're going to do about it, okay, how we can resolve them. So first, let me introduce myself. My name is Tal. I work at Wix.com. If you're not familiar with Wix, Wix is a platform for small businesses to manage themselves, all starting by creating a beautiful website. And it's not a small platform. We've recently crossed 100 million users, which is pretty exciting. So we are big believers in React Native at Wix.com. We've switched all of our mobile app efforts to React Native about a year ago. Okay, previously we had two stacks, one native for iOS and one native for Android, and we pretty much ditched them both about a little bit more than a year ago and moved over to React Native. And the Wix app, which you can see here on the right, is implemented from scratch in React Native. We have over 40 developers working on it in the day-to-day, and this number is rising every quarter. And being with React Native in production for over a year in a purely React Native app teaches you a lot, which is partly the reason I'm talking to you today. So, the promise for cross-platform. From the dawn of mobile, we've been hearing about cross-platform. Okay, there are many, many benefits to doing cross-platform. We want to share our skill sets. We want to share our knowledge. We want to share our code between iOS and Android, between mobile and the web. We want to be more productive. I think we want to develop faster. So there are many, many benefits to cross-platform. And JavaScript, of course, among all solutions, is the holy grail of that. And why is that? Because JavaScript is the only language that will let you conquer both iOS, Android, and the web. But this isn't really a new concept, okay? We've been hearing about it for quite a while, okay? We've been hearing about it since the days of Cordova and PhoneGap, which Mike mentioned. That was 2009. We've been hearing about it since Accelerator Titanium. That also has existed since 2009. So the concept is not new at all, okay? But it didn't catch on. None of these technologies has become mainstream. Okay? I am a native developer. You don't see native developers lined up to switch from native code to them. And why is that? So the skeptics would say shitty apps. But I would say that performance is the underlying reason. Okay? If you take the performance of those frameworks that try to use JavaScript as a means to do cross-platform development, you would see that the performance did not measure up to purely native apps. It is that simple. So the apps that you created with them did not feel as good as the native ones. Okay? And then we have a relatively new player in the field, React Native. Learn once, write anywhere with React and JavaScript. Lots of productivity coming from that space. So the pedigree is promising. Okay, it's coming from Facebook. And Facebook, since 2012, is a mobile-first company. Okay, most of the revenue that Facebook makes actually is for mobile today. So this is interesting. But the question still remains, does it measure up to purely native apps? So let's take a look at one screen from our app. Okay, this is a purely React Native app. And let's ask ourselves, what is the UI that we see here? Is this an HTML? Is this a web view like other implementations like PhoneGap or Cordova? And many of you are React Native developers, so you know that the answer is no. Okay, the views in React Native are purely native views. So from our app, the navigation controller that you see here at the top bar is UI Navigation Controller. Now, if you are an iOS developer, you would know that when you write in Objective-C or Swift, you use UI Navigation Controller. So these are the same UI views that you use in your native apps. And the button here is UI bar button item. The image view is actually UI image view under the hood. The switch is UI switch, the tabber controller is UI tabber controller. And if I had shown you the same screen on Android, you would see that the implementation is completely different, okay? It renders to the native views. Okay, so if the UI is completely native with React Native, where is the JavaScript? So the JavaScript is what is running under the hood, is where you are as a developer, you specify the business logic, you specify which components you want, and then the framework renders it for you. So let's dive into React Native a little deeper and see the architecture from the inside. So the architecture for React Native, okay, to understand the main point, is you have to understand that there are two realms running side by side in your app. You have the JavaScript realm, and you have the native realm. The JavaScript realm is where you program in JavaScript, naturally. The code there is running on a JavaScript engine, okay? Specifically in React Native, it uses JS Core, that is the open source JavaScript engine for WebKit. You are probably familiar with other engines like V8, okay? They're pretty much, they do the same things. And this engine is running inside your app on one of the threads, okay? Your app is a process, it has several threads in it, so JavaScript is just one of them. So what about the native realm? In the native realm, you still develop in Objective-C and Swift if you are on iOS, or with Java if you're on Android. You use the native platform-specific languages that you used before, and you have a main UI thread as usual in all platforms. Okay, you can usually change UI only from the main UI thread, and you can create as many background threads as you want. So these two realms are different, and connecting these two realms is the bridge, the React Native bridge, which is a very important construct here in this entire thing. Now, an interesting story, did you ever try to debug a React Native application using Chrome, for example? So when you do that, then you have the two realms actually running on different computers. Okay, you can run the JavaScript realm entirely inside Chrome itself, so you can debug it inside the Chrome debugger, and you have the native realm still running on your phone. And then, instead of going inside your app, you would go through a WebSocket. So the bridge, which is just a communication protocol, can travel over a WebSocket as well. So this is the concept. Now let's talk about performance. Okay, this is the main topic for today. So code that you write in the native realm, what performance do you expect of it? So naturally, we would say that we expect performance to be good, because that's like the regular way to develop in mobile. So performance in the native realm is excellent. Now what about JavaScript? Do we expect JavaScript code to be slower? Well, I think in modern JavaScript engines, the answer is no. JavaScript is a blazingly fast language, okay? Code that you write in JavaScript is not very much slower than code that you write anywhere else. So performance in JavaScript realm is actually pretty good. So where is the problem? What about the bridge? So let's talk a little bit more about the bridge. Let's say you have a variable in one of those realms, okay? One realm cannot access directly the variables, the data inside the other realm, okay? It's a completely different heap. It's a completely different address space. If you want to send data between the realms, you have to serialize it. You have to serialize it just like when you send data from a client to a server. And this serialization is expensive. It comes with an overhead. And this is something that is important to understand. This serialization takes place every time you send stuff between realms inside your app. And this brings us to the first conclusion of today. If you take something, one thing, out of this talk, I hope that this would be it. The key to writing performant React Native apps, the key to architecting them, is to keep passes over the bridge to a minimum. And we're going to see a practical example in a minute. Okay, so take away this and always think about what is going over your bridge. So let's talk about the obvious pitfalls, where most of the competition that we talked about since 2009 lost the battle. And the main performance pitfall is to having synchronous updates between realms. What are synchronous updates? Imagine that the JavaScript thread is trying to change something in native, then the JavaScript thread would be stuck until the native thread would handle it, and then it would continue. And you understand that making the entire system stuck until the whole process completes is a performance pitfall. But it seems that we have to have that, right? We need that for consistency, don't we? Because let's say that we have a JavaScript line that changes the color of a button to blue. And the next JavaScript line checks what is the color of the button. Now, if the update was asynchronous, okay, if the native side did not handle it yet, then the response that we would get in the second line would not be correct. And this is something that we need to take care of. So how is it working? So in React Native, actually, this is handled out of the box in a surprisingly impressive way. And who do we have to thank for that? We actually have to thank React for that. React.js actually solves a very similar problem on the web, because on the web, you have essentially the same thing going on. You have the JavaScript realm, which is your JavaScript thread, and you have the DOM. And the DOM is a native construct. And every time you try to update the DOM, the update is synchronous on the web. And the way React try to overcome this performance limitation is by introducing the shadow DOM. You have JavaScript updating JavaScript, and then React batches those updates and sends them together at once, kind of like double buffering in gaming. So this optimization is aimed at minimizing passes over the bridge. Okay, instead of updating every time, you update every once in a while, and you batch it together. So this is an idea, and this idea works remarkably well in React Native and achieves the same goal that we said, minimize the passes over the bridge. So this makes updates in React Native, updates between realms, asynchronous. So this is one of the secrets for React Native performance out of the box. But I want to show you a more interesting example. Okay, talking about the happy flow is happy. I want to show you a very trivial example that you would develop in your own apps that is completely immune to the out-of-the-box optimizations that React Native does. And this is surprising, so let's dig in. So the screen I'm going to show you is actually the main screen of the Wix app. Okay, I just updated the example from this talk. It's a few weeks ago. And in this screen, we have a very simple screen going on. We have a list of cards that we see here on the bottom, and the user can scroll that list of cards. And on the top, we have an image. This image is welcoming the user to the app. And we're going to have two cool effects here on this image. Okay? Notice the first effect, as the user is scrolling the list of cards, the image dissolves to the background. And the second effect is an overscroll effect. If the user is scrolling downwards when he's already at the top, he can't scroll anymore. And the way to give kind of a good feel is to change the zoom of the top image accordingly, just to make it feel continuous. So these effects may seem minor to you, but they are actually part of the last mile. The last mile is what makes a user experience magical. It's what separates the mediocre apps from the great ones. So you want to invest in those little things, and these things have to run at 60 FPS, or else you're missing the whole point. The point is immersion. So these two effects, we'll see how to implement them, okay? The dissolve and the scale. So the layout for this screen is very simple. Okay, if we want to lay this screen out with Flex or with JS6, we're going to have two components side by side, the image component on the background and the list view. That's it. Very simple. So let's start implementing that. Now, these effects are tied to the scroll position. Okay, as the scroll position changes, we want to dissolve accordingly. And as the scroll position changes upwards, we want to change the scale. So how would you implement that in a naive approach? So you want to go with JavaScript, and we want to hook up to the onScroll event of the scroll view inside the list view. That would be the natural implementation. So how would that go? So first of all, we have the list view, and I wanted to show you that the list view actually holds a scroll view. You can actually supply the scroll view by yourself to list view with a prop called render scroll component. So here I'm doing just that, and on this scroll view that I'm supplying, I'm hooking up the onScroll event. Very simple. And the implementation for this event would just implement our effect. Okay, our onScroll event handler will run every time the scroll position changes, and it simply takes the scroll position and it calculates. It checks. If the scroll position is positive, that means that the user is scrolling downwards. And then we want to dissolve, so we will change the opacity from 1 to 0. If the scroll position is negative, this means that the user is scrolling upwards in an overscroll, so we'll change the scale from 1 to 1.4. Very simple, and once we calculated the new values, we will just set state and re-render the image. So let's analyze performance. Let's analyze the number of passes over the bridge in this example. So the left side here in purple is the JavaScript realm, and the right side in black will be the native realm. So on the JavaScript realm, we start by setting onScroll. Now, the scroll component, as I told you, every component is a native component at the end of the day. So when we set the onScroll event, we actually have to go over the bridge and set the onScroll in native, because the view underneath is a native view. So we set the scroll, and then the user starts scrolling. And we have a scroll event. Now, the scroll event is a native event. Because all views are native, the events emerge from the native side. So we have the scroll event, but our logic that calculates onScroll is in JavaScript. We have to change and go over the bridge again. We calculate opacity and scale in the onScroll function in JavaScript, as I showed you before, and then we re-render. Now, when we re-render, the views, the properties that changed, have to go over the bridge again, because the view itself, the image, is a native view. So we have to go once again and update the view itself. And on the next frame, as the user scrolls a little bit more, we're going to have the same thing going on. So what can we see from this very simple analysis? We can see that data is crossing the bridge on every frame. Now, if your app is doing other things on the JavaScript thread, if your app is using the bridge for other purposes, okay, and you expect this effect to run at 60 FPS, then this is not what you'll get, okay? This is important to understand. So what can we do, okay? So first, we're going to try to implement this several times. So our second attempt, we're going to pull out the big guns. And the big guns are native, okay? We're running on a native platform. If we have a problem, let's just run there, okay? It's a trick we can always use. And React Native is actually very flexible for this task. The architecture of React Native allows us to take any component that we want and port it to native. We can switch anywhere. This is because a JavaScript component can contain a native component, and a native component can contain a JavaScript component. So you're free to design your tree as you like and port components from one side to another. So how can we reduce bridge traffic using this flexibility? Okay, so we're going to do the following. We're going to take one of our components. We're not actually going to port it, but we're going to wrap it. We're going to take our image, and we're going to wrap it with another component. So you can see it here. I call this component, just to be clear, native wrapper, because unlike the other components, this one we're going to implement not in JavaScript, but natively in Objective-C in a minute. So the idea here is, what was the problem with the previous implementation? The problem was that onScroll was a JavaScript function, and we had to go over the bridge with the event to run it, and then go, after we update the properties, go over the bridge again. So if we move onScroll to run in Objective-C, we could circumvent all of that problem. So that is the idea. So we will write onScroll in Objective-C in a minute. And the onScroll will be implemented as part of the native wrapper. Now, why did I put it there? Because the best thing is for the native view to update its own properties. It will calculate the opacity and the scale for its own, by itself, and it will change its own opacity and scale. And because it is a container, if you change opacity and scale of the container, the effect also influences its children. And this would work very well with the image. So let's try it out. So we're going to wrap the image with a native view and going to listen to scroll events there. This will be our second attempt. Now, I won't go into the entire implementation. I'll just want to show you some key things. One of the key things, which is a bit like the only challenging thing here, is actually to hook up the scroll event. This is a bit difficult because you need a pointer. You need some way to reference the scroll view inside the native code. The way to do that, in general, I will just give you the hint of the approach, is to get some reference to it. And the way it works in React Native is by using something called React tag or a node handle. This is pretty much just a number. It's a number that you can, it uniquely identifies every component instance. So you can use this number to translate and get instances of components. So we can calculate the instance, the number, the React tag of the scroll with the function React Native find node handle. And then we're going to pass this number as prop to our native component. Now, the key thing in our native component, after we have hooked up our onScroll event, is to implement the onScroll function in Objective-C. Now, this code is in Objective-C, so if you're not a native developer, it may seem confusing, but it's actually pretty much identical. Try to compare it to the implementation that we had before. It's doing the exact same thing. We're taking the scroll content offset, and we're checking if the scroll position is positive. We're going to change opacity from 1 to 0. If the scroll position is negative, this means it's an overscroll effect at the top. Then we're going to change scale from 1 to 1.4. That's it. And instead of setting state, we can just change the view properties directly because we're running in the native realm. Okay, there's no need for the whole set state thing with React. It's just direct view manipulation in native. Every native developer knows that's like the regular way to do it on the native platform. So the implementation is fairly simple in that regard. So let's analyze. We render the whole thing in JavaScript. The left side, I remind you, is the JavaScript realm, and on the right side will be the native realm. And we render, so it has to go over the bridge, and this time we set the onScroll event directly in native. The scroll event is a native event, as before, but this time, instead of running the opacity and scale logic in JavaScript, we're running it in Objective-C native on the native realm. So no, we don't pass over the bridge once again. And the update view can take place in the native realm as well because we're changing our own opacity and scale. And this happens on the next frames. So what can you see here? We've completely eliminated all passes over the bridge except for the initialization. So this will run at 60 FPS, and it's a great solution. It will fix the performance issue. And this is good, okay, but this is not ideal. We can probably do better. Now, why isn't this good? It's not good because you need native skill set to fix this. You even need to write it twice. If you were to implement this for Android, you would need to write it in Java as well. And this is annoying, okay? You would need a native developer with native expertise. And if you don't know how to write native code, you can rely maybe on open source. Maybe find somebody who already wrote a similar component and published it. So this could work. What we actually do at Wix is we follow the 10% rule in our teams. We have about 200 front-end engineers all over Wix. And among these 200, we maintain about 10% as native engineers. So about 20, I would say, would be like the goal if all front-end engineers worked on mobile. So 10% of our engineers are native engineers, and we keep them exactly for these purposes, okay, to take problematic areas in our app and port them to native. So this brings us to another conclusion. React Native doesn't mean the end of native, okay? Native developers will still have jobs even when if React Native takes over the world. So this brings us to the million-dollar question. Okay, the most interesting part of this talk, okay, or I would leave you with, like a problem and no real actual actionable solution. So for the framework, for React Native to be truly useful, we need to do the same from JavaScript. We need to be able to solve these things. We need to be able to resolve these performance issues without resorting to native code. Now, how can we do that? How can we design the framework to solve those problems? So we're going to do a third and last implementation of the exact same thing, but we're going to do it in JavaScript. And we're going to take a concept of declarative programming, and we're going to implement the whole thing declaratively. We're going to use the animated library. You probably heard about it. And the concept of declarative API is the following. Okay? It allows us to declare in JavaScript the complete behavior in advance. Okay, that's the idea behind declarative. You can declare the entire behavior from your code during the initialization phase. Then we can take this declaration and serialize it and send the declaration all at once over the bridge to a native driver. Now, the native driver is a general purpose native driver. You're not going to write it yourself. Somebody wrote it for you in Objective-C or in Java, and this native driver will understand the declaration, and it will execute the frame by frame for us. So this is the concept between declarative programming and how we use it to solve performance issues. So let's see what the implementation looks like, and I'm going to run over it because we're going to dig into it in detail in the next few slides. And which is the animations library, the excellent animations library that is part of React Native Core, it works by using animated values. And what we will do is we will supply to the list view, this time, not a regular scroll view, but we're going to supply an animated scroll view. And the animated scroll view is special because it allows us to hook up the scroll position to the animated value. We're going to go over this in detail in a minute, so don't worry about the code too much. The image will also have to change. We're going to change the image into animated image, okay? An animated image is just the same as it's like a higher order component that wraps image, and it will allow us to change the opacity and hook up the opacity and the scale to the animated value as well. So before we jump into the implementation itself, I want to analyze it with you. I want you to see where the performance benefits come from. So the first thing that runs on the left is the JavaScript realm, is the declaration. It runs in JavaScript. I'm going to take you back to the slide. You can see that the code here is completely declarative. It's all in JSX. We no longer have the onScroll function, which was imperative. In the previous two implementations, we've had an imperative function onScroll that does the calculation. Not here. Here, the entire thing is completely declarative. And this declaration is serialized and sent over the bridge. And this configures a generic driver on the native realm. And this native driver is the native driver supplied by Animated. We didn't write it ourselves. We're just using. It's part of the framework. And once there are scroll events emerging, the native driver by itself is going to do the calculation of the opacity and the scale according to what we declared that we wanted to do. And then it will update the views, and it will do that on every frame. So you would see that the analysis shows that it's exactly the same as the native implementation. But what's the big difference? I grayed out all the part that is not under the direct responsibility of our code, because the native driver does that for us. So this is the concept. So now let's dig deeper into the different parts of the code, because this is the most interesting part to understand. So the first part was the animated scroll view itself. It does very simple, the declaration is very simple. okay, it says pretty much for any scroll event that the scroll view has, okay, you can see that it shows on scroll, take a field from that event. And the event that we want to take, the field that we want to take from the event is the field called content offset. That's what the declaration says. Once you take that content offset, just save it inside an animated value that I provide. Okay, you can see it on the far right. You see the underscore scroll y. Okay, this is our animated value. That's it. That's all the declaration, what the declaration says. Now, the second interesting part is how we change the opacity in a declarative way. Okay? So this is also very simple. We're going to take the animated value that we have, and at any given time, this animated value will hold the scroll position because of the previous declaration, and we're going to interpolate it. We're going to tell how to take any given scroll position value and get the appropriate opacity value from it. Okay? So it works by giving an input and an output ranges. So if the input is 0 to 250, and this is 250 logical pixels in scroll position, the opacity will translate to 1 to 0. Okay? So as you scroll, it will get to 0. And the second part is exactly the same. It's the same interpolation of the animated value that we have, and it will take the input range, which is different, negative 200 to 0. This is the overscroll that we had, and it will translate it to 1.4 to 1. Okay, this will give us the scale change that we wanted. And this brings us to the future of React Native. The future of React Native is to solve more and more scenarios, like I showed you, without native code. JavaScript API that reduces passes over the bridge. Okay, this is the future. And the declarative native of React, in general, is going to be a big help for us in this process. I don't know if any of you watched React Conf just like a few weeks ago. I demonstrated there a library called Interactable that does pretty much the same approach and does like physical interactions. So it's a very similar declarative approach to performance issues with React Native. Now, you have access to the full code of the 3 implementations just to see them side by side. The code is here on GitHub, rn-perf experiments 2. One was like the old example. I changed it up to show the new API, like animated scroll view. So you have that available on GitHub, and you have a small demo app. And the cool thing about this demo app that it lets you run the 3 implementations side by side. And it has a little switch. Because it's just a small demo app, you will not see performance issues there. So what the switch does is it simulates a busy app, like our big app. Okay? It just takes and it sends tons of stuff. It makes the app really busy over the bridge in the JavaScript thread. And I'll show you a small video of what it looks like. So if you turn it on and you try the JavaScript implementation, you can actually see with your own eyes in a stress condition how the performance behaves. It is not smooth at all. So it has been stressed just to show you how it behaves. And the native implementation is, of course, silky smooth at 60 FPS under the same stress conditions. And the animated example use native driver, okay? Native as well, the native performance. So this is how it works. You can follow me on Medium. I actually wrote a few days ago a post detailing this entire talk in much more detail, going over the code examples with more detail. You can see it there under my Medium account. You can also follow me on Twitter. I have a lot of tweets about what Wix is doing in this space and how we bring native performance to the React Native space. So thank you.